Hey guys, so we're going to go over your checkups here. I haven't given everybody feedback or a score on this, and that's just because they take a long time. You guys did a lot of writing to grade, so you guys will be collecting these, turn them back in when you're done with this video. But I wanted to just go through it so that you've got some immediate feedback, because I figured if we took this on Wednesday and we waited all the way until Monday to talk about it, that wouldn't be great. So what I've done here is I have the test on a couple of slides, and then I also have, I've created the scatter plot and put it on a calculator. So some of you used the calculator to compare statistics. So your data was height and weight of students, okay? Now this was the height and weight of a bunch of different students. This was not the height and weight of one student as they aged or anything like that. So that's one misconception I think I found in a lot of the answers, was people were saying things like as you grow and over time, but this isn't necessarily people growing. This is just different people, okay? This just different students. So let's take a look. Here's what my scatter plot looked like. You can see on the graph I have my height as my x-axis and the weight on my y-axis, and then I've created a linear regression line, and we'll talk about those things first. Or later. I want to first talk about, the first question was, what was the correlation of this data? Well, looking at this scatter plot, I can see, I know it's positive. The data points are going up. If we look at the actually R value, that correlation coefficient, it's 0.77, and we know that closer to 1 is stronger and closer to 0 is weak or no correlation. So this is 0.77. I think it's right on the line of what you would call weak or strong. So some people said weak and argued that. Some people said strong and argued that. And I will accept both of those answers. You just had to provide some kind of justification for that answer. And then you were also asked, what does that mean in terms of the two variables? Well, that means that people, not as you grow, but people who are taller tend to weigh more. People who are taller tend to weigh more. These tall people weighed more than the short people. So then in the same way, people who are short tend to weigh less, okay? People in the middle tend to weigh in the middle. Now you have these people that aren't really tall, but weighed more. And those can be some things that we'll talk about, and a couple of you did. And a couple of you said things like you could just weigh a lot and be short, which happens. But what we're seeing here is a correlation. People who are taller tend to weigh more. People who are shorter tend to weigh less. Okay? That leads into the next question was, is there causality here? Some of you argued yes, but I will say that the most of you that argued yes said as you grow, you weigh more. But keep in mind, this is a bunch of different students. So does being taller cause you to weigh more? Does being shorter cause you to weigh less? I think you could argue both ways. How I'll grade that is really, and on the test we'll maybe amp this up a little bit, but it's mostly about, can you defend your answer? Does this really cause this? Does being taller cause you to weigh more? Okay. So that was the correlation causation piece. That's more learning target 1, representing it, and then talking about how the variables relate. Then getting into, you guys were asked to create your own line of regression. You needed 2 points, so a lot of you chose 2 points, and then from those 2 points, you used the y1, or y2 minus y1 divided by x2 minus x1, and you got your slope, right? And then you used your slope to get your y-intercept, and you should have your own equation there in the form y equals mx plus b. This is the equation. I'm going to use this equation to talk through the points, but you were asked to use your slope and your y-intercept to talk through what it meant. So hopefully you got somewhere around here, and I think for the most part people were getting 8, 10, somewhere around there. And then this y-intercept was really throwing people off because it's so big, we're so negative, and then also just doesn't make any sense, but we'll get there. First I want to talk about slope. you were asked, how does your slope, or what does your slope mean in terms of the height and weight? Well, if we use 8, and I'm just going to abbreviate or estimate this to 8. So if we use 8, that's 8 over 1, right? Which would be our change in y over change in x. So that would be a change in height over a change in weight. So for every inch, or wait, no, change in y would be weight. Change in x would be height. So for every inch you are taller, not inch you grow, but inch you are taller, you tend to weigh 8 more pounds, according to this model, okay? So that's, on average, what the calculator is deciding. For every 1 inch of height, there's 8 pounds that go with that 1 inch of height, okay? So for 2 inches, it would be 16 pounds. That's what the calculator has decided is our relationship, okay? So as the height goes up 1, the weight goes up 8. As the height decreases, if you are 1 inch shorter than somebody, you might weigh 8 pounds less than them, according to this model. If we were using this to estimate, because we don't have anybody who's 70 inches tall, so we would estimate that they would be whatever this is here, between there. So we can use this line to estimate those values. Okay, the y-intercept, this negative 397.98, really makes no sense. That would mean if somebody were 0 inches tall, then they would weigh negative this much weight, okay? I think what's happening is that our data just points down so far. And it really doesn't make sense to talk about people who are less than, I don't know how, I mean, less than 60 inches tall. That would be 5 feet, or I guess if it's students, we can go lower. But you get to a certain height, and you don't talk about it anymore because those are going to be toddlers and children and babies, and then even babies are born with a certain amount of length, right? So that you get to a point in this x variables where it doesn't make sense, okay? So really, since the data is from just this 60 range to 70 range, we can really only talk about this 60 to 70 people, okay? We can't think that, I mean, we can maybe use this model to make predictions about 50-inch people, but not necessarily lower than that, because there has to be a plateau of where the weights kind of start off, okay? So, and I know this one confused a bunch of people. It'll be fine if you justify just that that didn't really make that much sense, and that's fine, okay? Then you were asked to give your equation and talk about why you put your line where you did. Were there more or equal amount of points on the top and on the bottom, or did it touch a lot of points, or just talk to me a little, or hopefully just talk to me a little bit about that there, okay? And then let's move on to the causality piece. You were asked to choose one of these that had causality and one of them didn't, and then defend both of your claims. So a lot of people, or obviously most people, chose the study hours and Regent scores as the one with causality. And if you argue that, if you know, okay, I'm going to argue causality, then you can argue that if you study more, you should do better on the test. And you can see this data shows that correlation. But I would also say that it shows causality because studying more gives you more information. More time with the information should make you have a better test score, okay? Now you can see these people all studied 7 hours and got 3 different test scores. So it doesn't necessarily guarantee perfection. 7 doesn't necessarily guarantee perfection, but it does say you'll probably do better than if you only studied an hour if you didn't study at all. Okay. On the other hand, this jars of strawberry jam sold in New York and the number of CDs sold in Florida, those two things are not related. Although they are correlated here, they're not, like the number of jars of jam sold in New York obviously does not affect the number of CDs sold in Florida. But somebody could make a commercial here and make some ridiculous claim that the two have causality. Hopefully everybody realized that this is not a causality. This is just simply a correlation. These things happen to correlate. All right. So again, I'll take those back if you wanted to. I mean, this is not a formative or a summative assessment. So if you wanted to kind of add on to it or jot down some things, that's fine. You guys are going to turn those in, and then those of you that still need to turn in the focus problems and write up from the other day can take the rest of the time to work on that, turn that in, erase your name from the board, and then everybody else you're going to get onto your Khan account and better yourself at some other areas of math. So maybe stretch yourself in geometry or something like that.